All right, so I think I'm recording here. Let's take a look at problem number 6. We're trying to find the domain of this relation. Well, we know that the domain is the set of all real numbers, excluding any values that cause division by 0, or excluding any values that cause us to take the square root or even root of a negative number. Well, I have both here. I have a variable in a denominator, so I have to be concerned about division by 0, and I have a variable underneath a square root. So I have both of these restrictions happening at the same time. If I just had the square root and if it wasn't in the denominator, then I would have 3x plus 2, and I could allow that to be 0. But the problem is that I can't allow this to be 0 because it's in a denominator. So I have to keep this 3x plus 2 to be strictly greater than 0. See, we can take the square root of 0, we just can't divide by it. So this is what I need to solve for in my inequality. I need to subtract 2 from both sides. I need to divide by 3. So I need to pick values in my domain that are strictly bigger than negative 2/3. Well, let's draw it on a number line. We've got 0 here, we've got negative 1, and negative 2/3 is between there. It's about right here, say. And if I want values in my domain to be bigger than that, I need all of these numbers that are to the right. So to describe that infinite set, I can't list them all. Let D be the domain. Negative 2/3, we don't want to include it in the domain. We need it to be strictly bigger than that, because let's take a minute and see what if somebody argued with me that they thought that negative 2/3 should be in the domain. Then that means that negative 2/3 will be related to some y value. And then the relationship is described with this equation. So let's plug in negative 2/3 into this equation and see what we get for y. So in the numerator here, we have negative 2/3 minus 4. Take that absolute value. And in the denominator, we have 3 times negative 2/3 plus 2. Okay. So in the numerator, this guy will give me what? 14 over 3. Because I can rewrite 4 as 12 divided by 3. Negative 2 minus 12 is a negative 14. And if I take the absolute value, yeah, I'll have 14 over 3. Now in the denominator, this 3 and this 3 cancel, and I have negative 2 plus 2. Well, that's the square root of 0. I know the square root of 0 is 0. I don't have a problem taking the square root of 0, but to take 14/3 and divide it by 0 is undefined. So I claim that this negative 2/3 that we were trying to figure out, what is it related to? It's not related to any y value, not through this equation. It's undefined. This equation does not define a relation of x equals negative 2/3 to any real number. So therefore, we don't want that in the domain. We only want values in the domain that we can relate to some value in the range, to some y value. So I'm convinced that this is my right answer for the domain for problem 6. I hope that helps.